All right, today I'm going to talk you through the basics of using the circuit board. So I want you to see here I have a battery within a battery pack. This is a 1.5 volt battery, and we will be making sure we place this in the right place. Be sure to pay attention to where the cathode and the anode are. I've got wires. I've got all kinds of wires. I'm going to do some connections here. I have some light bulbs. These are resistors. We're going to be running electric current. The light bulb will indicate that. I have a switch that I can close or open, right? Opening and closing circuits are going to be important for us to be able to get current to flow. And I've got a couple of extra backup steps. So I have plenty of materials to work with. So here's what we're looking at. We're applying the concept of Ohm's Law. Ohm's Law is voltage equals current times resistance. And if I look at what Ohm's Law is, you'll be able to see that everything we do in terms of involving electric circuits is going to be applied to Ohm's Law. So voltage is going to be what we'll look at using with our batteries. Batteries are pushing current, right? So voltage is going to be this chemical potential difference that is on either terminal. So cathode, anode. We'll talk about the direction of current here very shortly. Current, we're going to be able to indicate by how bright the bulbs are, and resistance is something we'll be able to measure. We can quantify this as well. So let's try this. I'm going to go ahead and set up a simple circuit. I've got my battery hooked up here. I've got a switch, and I have a light bulb. Now, we don't have to make this very complex right here, right now. I've got it somewhat dark, just so that we'll be able to get the light bulb we can be able to see the light bulb a little bit more readily, easily. But notice here, I have a closed circuit. If I open it, bulb goes out, I stop current altogether. So then again, if I close it really quickly here, you'll see that I get the light to come back on. I want you to pay attention here that if I increase the voltage, so notice I'm going to add another battery here, and that increasing voltage is also going to increase current, and as a result of that I'm going to get a brighter bulb. So here's what I just did. If I go back to Ohm's Law, if I double my voltage, remember I kept resistance constant, I only had one light bulb here. If I double the voltage, I double the current, and we can get an indication as to the current by seeing it's brighter. So brighter is going to tell me that it's got more current moving through here, moving through this circuit. Now I want to pay attention here because a lot of times we make this mistake. You have to make sure your cathode is directionally consistent with your other cathode. I have two batteries here. That my current, based on conventional, it says that current's going to flow from my cathode to my anode. But my electron flow, or the modern view, is going to say that electrons are actually being pushed from the anode to the cathode. So we'll sort that out as we go here. But notice I'm going to break the circuit, light bulb goes out. We're going to go back here and look at what happens when I add yet a second light bulb. That if I change the amount of resistance, right? If I increase my resistance here, I'm going to decrease, right? If I increase resistance now, I doubled my resistance, I'm going to decrease my current, right? I haven't changed my voltage. My voltage is still this. My two 1.5 volt batteries, right? A total of 3 volts. That stayed constant, but notice the brightness went down. The brightness went down because I now have 2 resistors that are going to decrease or cut my current in half. All right, open, close. So just to make sure we're understanding what's going on with the concepts here, I'm going to throw another wrinkle here, and I'm going to put on here what's called a potentiometer. This is what we call a variable resistor. Many of you are familiar to this. It just doesn't look quite like this. This is a dial. This is actually controlling how much resistance is in the circuit. And if I turn the dial, I can increase the resistance enough to where the bulb goes out altogether. Notice it's still a closed circuit here. But if I decrease my resistance again, right, decreasing resistance, this is my dimmer switch. If I have the resistance as low as it gets, I have as much current as I can get here. And once again, here's my dimmer switch. So this dimmer switch, by me turning this dial, changes the amount of current that is traveling through this particular circuit. So before we move on here, I just want to make sure we reiterate what we have going on. As we focus on Ohm's Law, we'll find that everything's mathematical, that Ohm's Law, voltage equals current times resistance, is going to kind of be the end-all be-all for what we're studying here right now. There's the first part of our videos.